Assalamu alaikum. Hello, sir.
Walaikum Assalam. Saad, can you hear me?
Yes, sir, I can hear you.
Okay. Saad, I had a word with your father, and he told me that you need some assistance in A level, perhaps physics or something like that. Now, can you tell me about? Can you tell me a bit about the plan? That have you done O level from GCE or from IGCSE?
IGCSE, sir.
And you did it from UAE, Dubai. You were in Dubai for IGCSE.
Yeah, Abu Dhabi, sir.
Okay, that's good. Now we can do some work. You have to start your college, your school, whatever you say. It's end of, I think the school start by the end of August, and the results are going to come in the mid of August.
Yeah.
So what you are looking for, are you planning to do some work ahead of the school, or you want to revise something specially?
No, sir. Sir, I want to go ahead on the school. Do
Okay,
work beforehand.
some work, some syllabus, and you are planning to do A level from GCE Cambridge, right?
IGCSE, yeah.
But IGCSE won't continue anymore because all A levels are on GCE. So it means that you are going to do GCE, and we call it syllabus 9702. I'm showing the code so that later if you have any change, sometimes schools in Dubai, in Abu Dhabi, some schools also or go for Edexcel A level. So whatever it happens, we can manage it because the main theory concepts are the same. Paper pattern are changing. Let me introduce you some basics about AS level physics. This is a new syllabus from 2022, and the syllabus code is 9702. So this is called GCE A level physics, and it is 9702. This is
Okay.
GCE A level 9702 for the reference. I'm giving you an introduction. I hope you can see my screen.
Yeah. Yes,
Okay.
sir, I can hear.
And this is syllabus 9702. If you will follow that, it will be a Cambridge International A level, and it is divided in two parts, AS and A2. The main sections of the course are physical quantities and measurement. Second is mechanics. Then we have waves and electricity. I have changed the color to highlight that these two sections are relatively more difficult. The last section is called nuclear physics. So these are 5 units, 5 sections in A-level physics. Now, when we talk about the chapters, they are physical quantities, kinematics, dynamics, work energy, power, deformation, waves, superposition, electricity, DC circuit, particle physics. There are 11 chapters in your course. How the
Okay.
paper work out here in our Cambridge system, there is one paper, which is paper 1, that is dedicated to MCQs, paper 1. Like, had you done extended physics or core physics in O level?
Extended, sir.
Okay, then you must remember paper 2. Okay,
Yeah.
paper 2 was MCQ paper. It's a publication of that, and there
Hello,
we
sir.
have 40 questions, and this is a MCQ paper. Then you
Sir,
might
I can't hear you.
okay, now can you hear me? Can you hear me now? Hello, can you hear me? Saad, can you hear me?
Yes, sir, I can hear you.
Okay, paper 1 is a continuation of paper 2 last year. Now, do you remember paper 4 last time, the core theory paper?
Yeah.
Okay, now just like paper 4 in AS level, they have paper 2. It is a 1 hour, 15-minute paper, and there are 60 marks for it. It is called structured paper. Now, do you remember last year, paper 6?
Yeah.
Which we used to call as ATP.
Yeah. Alternative
alternative to practical, and that was paper 6. Now, as a contrast, this year, you will have to attempt a physical practical in a laboratory, and they call it paper 3. It's a real paper lab, it's a paper work, and it's a paper work with the lab support. You will have to go in the laboratory, you have to set the apparatus, you have to make some calculations, and you have to draw a graph. It's a fully loaded paper 3, which is actually an actual exam practical work. The support which we use in CI as our O-level style, we have a syllabus to follow. We have marking schemes, examiner reports, yearly past papers, June, March, and November. We follow topical, which I actually prefer when I'm teaching. Sorry. I prefer topical past papers. Topical past paper, just like you complete one chapter and sorry, and do the past paper along with it. Then we have a student response booklet, which is a very helpful thing. You might have seen it in O-level also. These booklets are actually helping students to identify the good solution, the poor solution, the mistakes. Now, the books which we will be using, and you have to wait for the school to come up, and they will also guide. This is a very good book, which is like a dictionary, complete physics. And then we have a Cambridge endorsed book, 3rd edition, this one. And this is a very famous book. Nearly every teacher, student refer this book. This is physics main book endorsed by Cambridge. This is a past paper topical book, paper 1, paper 2.
Yeah.
Now in O-level, you have done the same Cambridge system. So you know there are two important things for which students are taking classes. They need correct concepts, and they have to connect the concepts in correct. So what examiners are looking for in A-level, the marking system is much higher. That many theories will continue, many concepts will continue. The main challenge comes because examiners are more in demand. They want good quality work as compared to O-level. They want more work. Now, we are starting our first chapter, physical quantities and units. So if you have a copy, give the heading, physical quantities and units, chapter number 1.
Okay, sir. Okay, sir.
Now, the main topics of this chapter, physical quantities, SI units, errors and uncertainties, scalars and vectors. As A-level is much harder than O-level, and actually level goes because of the examiner's requirement. Now, you have to remember that you need to make some lists, some topical work, some routine, organized follow-up of homework, online quizzes, which I prefer a lot because this will help you to gear up, because A-level is a short session. Hardly 5 to 6 months it takes, and the AS level completes. So the first chapter main topics are physical quantities, SI units, errors and uncertainties, scalars and vectors. You have to copy this screen.
Yes, I'm doing it right now, sir.
Let me know once you have copied it.
I'm done, sir.
Okay, that's very good. And now this is the topic list. Now I'm starting with physical quantity. I'm putting the first concept for today, that what is a physical quantity? A quantity which has a magnitude and a unit. For example, length is equal to 5 centimeter. What is 5? 5 is the
quantity.
magnitude. And what is centimeter? Unit. So magnitude and unit together, if you combine, you will get a physical quantity. Physical quantity is the combination of magnitude and unit. Physical
Okay.
quantity is a combination of magnitude and unit. Okay. So whenever you combine these two things, you will get a physical quantity. So give the first heading of the topic, the first heading in the chapter, physical quantity.
Okay.
Write under it that a quantity with a magnitude, and a unit. This is the definition.
Yes, sir. I love that.
A quantity with a magnitude and unit. For example, and copy this example.
Yes, sir.
Copy this example.
Copy that. Okay, okay. Done, sir.
Good. Now, there are two types of physical quantities. One is called base quantities and second is called derived quantities. One is called base quantity. Let's make the concept first. What is a base quantity? Something like a science. Whenever you start a science, you need some fundamental quantities. Like whenever you start a language, you first need alphabets. Okay. Alphabets combine to form words, and words combine to form sentences. Similar, science works in the same way. You need some foundation figures. This is like the alphabets, and in physics we call them base quantities. Like in chemistry, you must remember, I think you had chemistry also then, because it looks you are a science student. Like in chemistry, we had elements like silver, iron, gold. These are called the fundamental quantities. Base quantity is something which is the making the foundation of physics. Now the base quantities combine to form derived quantities. Sorry, I have a flu problem. Sorry for the interference. Now, what is the concept? A base quantity is that which is the foundation, which is the foundation of the subject. There are some quantities which started physics and they are called base quantities. The quantities which are obtained from the base quantities are called derived quantities. Just like sentences, words are derived from the alphabets. Okay, this is our second concept for today. You have to copy this screen.
Okay. So do we have to learn any definition of base quantities and derived quantities?
Yes, that's a good question. Acha, let me know one thing, Saad, how you classify yourself. This is a very important question I always ask. Do you classify yourself a self-motivated student, or you always need a follow-up?
Self-motivated.
Then it's good. Then it's a very good thing. I asked this question because you asked a question and then notified me that you are looking to be self-motivated. That's very good thing. Because nowadays, the problem is not that the resources are not available. Resources are overcrowded now. The problem is now reversed, that you need to arrange yourself to manage the resources. The word which I always tell to my all students in my first and second class, that A level is controlled by topical past papers. No need to buy any book. No need to buy expensive notes. The classwork and digital notes are more than enough. A level is actually designed to test the understanding. AS level is designed to test the understanding rather than the memory. The reverse will occur in A2. In A2, they will test your memory as well as the understanding. So AS will be very good for those people who are able to line up themselves and they work together. They work with the documents like marking scheme, examiner reports, student response booklet, and the obviously the videos, animations that we are supportive. I have a website also, and this is a new idea which I have been working for the last 1 year, and I'm trying to collect all the resources in one place, because now every good student faces a problem that suppose you want to work out, suppose work energy power. Now so many resources are available that you can't filter out what to do. So I'm making a website. I will share the link with you also. That will be helpful to you. So you can take, if you are working on one chapter, because we will go for topical. So all the resources will be under that one page. Now, as you asked base quantity, but before starting base quantity, I want to recall what is System International. Do you remember
International.
SI, System International?
Yeah.
When people were working on different units, for example, centimeter, meter, kilometer, and foot, etc. This was a confusion for people working across the world. Some people were working in centimeters, some were working in meter, kilometer. So there was no unification. So some people together thought about a unification system. What is the idea of unification? That let's agree on one unit for every quantity. For example, meter is defined as an SI unit. This is called System International. It is a unified system of units and quantities, because we need unification, so that if you make something in Pakistan and you want to sell it to anywhere else, the other people can get the same standard. They can understand what you are selling. So now come to SI, base quantities. Make the concept that base quantities have made the foundation of physics. They are the pioneer in the subject. You can see the definition and you can copy it.
Okay. Done, sir.
Now this is the definition, and now I want to recall you from O-level physics that what are the base quantities: mass, time, length, current, temperature, quantity of substance. Luminous intensity might be new for you, might be. Now there are 7 base quantities. What is the meaning of 7 base quantities? These 7 quantities started physics as a subject. These 7 quantities started physics as a subject. I will post this table to you, and you have to recall and remember it as a memory. Now, what are derived quantities? Derived quantities are obtained from the base quantities like volume, area, speed, etc. You have to copy this.
Okay. So basically, sir, base quantities is scalar quantities, and derived quantities are vector quantities.
Base quantity can be, if you look on this table, mass, time, length, current, temperature, this is a chance that they all are scalar, but the nature is not necessarily scalar. It's only a chance that the people who are starting this subject, they put it like that. For example, length. Okay. Length is by nature a scalar, but do you remember displacement? What is the unit of displacement?
Meter.
Meter. And displacement was a scalar or vector?
Vector.
Very good. So it means that what is the base quantity? Base quantity was the foundation of physics. There were 7 quantities. There were 7 quantities which started physics as a subject. Then these quantities intermingled and they made a huge range of quantities which are called base quantities. You have to copy this.
Okay.
Have you copied it?
Yes, sir.
Okay, let's quickly recap what we started today. We first made an introduction of our AS physics, and this is the first chapter, physical quantities and units. We made the list and we first introduced the concept of a physical quantity, something with a magnitude, something with a magnitude and a unit. Then we put a concept. There are two types of quantities, base quantities and derived quantities. Then we discuss the concept of SI base quantities. Now the base quantities are those which made the foundation, and these are the 7 base quantities. Now derived quantities are those which are made from that base quantities. Examples of derived quantities. Now give a heading, examples of derived quantities.
Yes, sir.
Now I'm starting with very fundamental example, and that will develop our first main topic in the syllabus. I have shown area as length into breadth, meter square. I have shown the multiplication. This is a very important skill that you need to understand how a unit appears: volume, meter cube, density, mass upon volume, and then Newton for force is actually kg ms minus 2. You have to copy these examples.
Done, sir.
Now look at this example, which will make our next concept. Newton is the derived unit. And what are these 2, 3? These are called
Base quantities.
base units. So Newton is the derived unit, and kg ms minus 2 are called the derived units. Now v is equal to d upon t. Then acceleration is equal to velocity upon time. Can you tell me that if there is a s below, how it becomes s minus 2 indices? Maths. When you bring something from the denominator and if you get it up, will it become negative?
I don't know. I don't understand, sir. Sir,
Look at simple maths, 2 upon x. Okay, can I write it 2x minus 1?
yes.
Good. So I have ms minus 1 upon s. It's 1. So I take it upside and I get again s minus 1. So there are 2 minus 1. When
Yeah,
they add up together, they get
ms minus 2. Yeah, I
ms
understand.
minus 2. This is a very important exercise in the start of this chapter. Now see pressure, formula force upon area, Newton per meter square. Now look at this Pascal. Pascal is considered as a derived unit, but this area is called this area is called as what? Base
Base.
units. Okay. So Pascal is a derived unit, but it actually means kg m minus 1 s minus 2. So whenever you talk about pressure, pressure is actually kg m minus 1 s minus 2. Whatever quantity becomes kg ms minus kg m minus 1 s minus 2, it will be considered as pressure. Now you have to copy this screen.
Oh, yeah. You can cut it short.
Let me know once you have copied it.
Done, sir.
Good. So this is the concept of base units, and every derived unit actually comes with a base unit. Now I put another O-level example which will connect me with A-level. Work. Work is actually like energy, and what was the unit of work? The unit of work was joule. We consider joule as a derived unit. But what is then this kg m square s minus 2? I'm sorry. And this is considered as a
Base unit.
base units. So it is a very interesting concept to understand that whenever you talk about a derived unit is a composite of small units which are called base units. Every formula can be converted into base unit. This is the first main exercise of this chapter. Okay, now you have to copy this example. If you get a query during copy, you should always ask on the point.
Okay. Done, sir.
I is equal to Q upon T. Q is equal to IT. It's ampere into second. Ampere into second is coulomb. Normally, what they did, these British scientists, they used the names of their scientists to put the unit titles like joule, like coulomb, like ampere. So the formula is famous. Current is there. Current is charge upon time. So I rearranged it. I made Q as the subject. So coulomb is ampere into second. You have to copy this ninth example.
Okay. Done, sir.
Now, this is just like our Hello I class, and we are keeping it up to here. By now, we have discussed the introduction of our subject. We made some initial concepts. And if you have any query by now, you can ask me.
Okay. Sir, why is the indices in like acceleration and velocity? Why is like the ms-1 and ms-2? Why isn't like ms squared or ms?
Look, this is a case that actually acceleration is velocity upon time. So when you write it ms. Now, as a variable in mathematics, s can go with s only. If I ask you to recall an O-level interesting concept, 2x square y upon x, can you recall where x can cut out with?
No, sir, I understand that, but like I don't understand like why like the indice on top of like ms on for velocity ms-1, why is it -1?
Because of the velocity formula, na? Velocity is equal to displacement upon time.
Yeah,
What is the unit of displacement?
meter,
What is the unit of time?
second.
Now move s upward.
So ms-1. Okay.
Got it?
Yeah.
Okay. This was our first question. If you have any other question, please go ahead.
Nah, I think it was only this one, sir.
Okay, now we keep it up to here, and we will talk inshallah again. Thank you for the time. My name is Faisal. Thank you. Allah Hafiz. Bye.
Allah Hafiz. Thank you, sir.